3.3. Prove lines are parallel. Our standards are shown here for 3.3. The objectives are for 3.3 and 3.4 are to find and use slopes of lines and to prove lines are parallel. Prove lines are parallel. Recall the definition of converse. It's a statement formed by exchanging the hypothesis, what's after the if, and the conclusion, what's after the then, part of a conditional statement. You switch the if and the then. Example, if you're a clown, then you're funny. The converse is, if you're funny, then you're a clown. In section 3.2, we learned that if two parallel lines are cut by transversal, then the pairs of corresponding angles are congruent. We're going to do the converse of that. The converse of that is, if two lines are cut by transversal so that the corresponding angles are congruent, then the lines are parallel. So now, it's kind of like that last proof we did in the warm-up. Now we're showing lines are parallel because the corresponding angles are congruent. Before, we were saying we knew the lines were parallel so that we could say the corresponding angles are congruent. We're doing the converse of that now. Here's a picture of what we're talking about. So with the original statement, our if would be M and N are parallel. And our then would be, therefore we know 1 and 2 are congruent. The converse of CA, corresponding angles, the if is 1 and 2 are congruent. And the then is, we show the lines are parallel. As you will see, you can do the same thing with all these other parallel type postulates. You can do it with alternate interior angles, alternate exterior angles, and so on. Find the value of x that makes M parallel to N. We need the corresponding angles to be congruent in order for M to be parallel to N. So these two things would have to be equal to say M is parallel to N. I can do that by setting them equal to each other. 3x plus 5 equals 65, and we're going to solve for x. So 3x equals 60, x equals 20 degrees. Questions there? Okay. The alternate interangles theorem. The theorem says if the lines are parallel, the alternate interior angles are congruent. The converse says if the alternate interior angles are congruent, then the lines are parallel. So here we have, on the left, we have parallel first, and then we say the angles are congruent. On the converse, we have the angles are congruent, so we can say the lines are parallel. Alternate exterior angle theorem and the converse. So with the alternate exterior angle theorem, we have the lines are parallel, so we can say the alternate exterior angles are congruent. With the converse, we have the angles are congruent, the alternate exterior angles are congruent, so I can say the lines are parallel. Questions? Everybody have it? All right. Consecutive interior angle theorem. What do we know about consecutive interior angles? They are Seth, what are they? They're not congruent, they're Faith? They're supplementary. Okay, they're supplementary. So with the theorem, the CIA, we have parallel lines, so we can say the two angles would be supplementary. They just plugged in values that would add up to 180. The converse, I would have with the consecutive interior angles, I'd have a combination that adds to 180, so then I can say the lines are parallel. So if you use these second theorems, you're just going to write CONV in front of AEA or CIA or AIA. CONV stand for converse. Okay, the converse of that. All right, how can you tell whether the sides of the pattern are parallel in the photo of a diamondback snake? So they've got this pattern. They show a close-up. These two angles are congruent. How do I know that these sides are parallel? What would it be? If these two angles are congruent, what would that be? Which one? What are those two angles that are marked? Here and here. What is their relationship? Eric? Okay, they're alternate interior angles. Now we are using them to say lines are parallel. So is it AIA or converse of AIA? Yeah, it's the converse. All right. Is there an example? Is there enough information to conclude that M is parallel to N? What do you think? What could we do? We've got, we've got the two angles. They're not corresponding angles. This is kind of a tricky question. What could we do to show that the lines are parallel, given that information? Well, you might observe these two add to 180, right? But they're not interior. If they were interior and they added to 180, then we could say by converse of CIA, consecutive interior angles theorem, the lines are parallel. If this is 75, what do I know this angle is? Jacob?
105.
105. Right. So if that's 75, this is 105. If this is 105, what is this angle? Aaron? 75. Now can I say the lines are parallel? By what, Aaron? They're not alternate interior angles. What are those two? Yeah. They're not exterior. They're interior. They're inside. What are these angles? Yeah, they're consecutive interior angles. And they're supplementary. So by converse of CIA, I can say the lines are parallel. So there is enough information. Well, let's look at the other one. Can you prove the lines A and B are parallel? 1 plus 2 equals 180. Does it matter that 1 and 2 equal 180 in this situation? We're looking for them to, what are 1 and 2? What's the relationship? Gunnar? They're interior, and they're on opposite sides of the line, so what are they called? Brandon, what's that called? Inside? Yeah, but which ones? They're on opposite sides of the line. Go ahead. Yeah, they're alternate interior angles. So for these lines to be parallel, what the 1 and 2 have to be? Not add to 180. What do they have to do? They've got to be the same. We don't know that. So we don't have enough information. The only way we would have enough information is if in what case would these could we say these are parallel? If 1 and 2 equaled what? They'd both equaled what? 90. That would be the only situation. If they both equaled 90, then we could say the lines are parallel. We don't have enough information. Prove the converse of alternate interior angles. So we are given that 4 is congruent to 5. That's marked. We have to prove that line G is parallel to line H. Now remember, we can't use AIA or converse of AIA in our proof, since that is what we are proving. So we have to use other things. So, we state our given first. Well, they gave you all the steps there. Let's go back. Let's do it step by step. I'd like to think through it. So we've got 1. Angle 4 is congruent to angle 5. And that is given. What else can we say? What other angles are congruent in this picture? And by what? Yeah.
5 and 1.
Why? That's what we're proving. What other angles are congruent? Abby? Well, that's given. We already got that. Yeah, go ahead. Kayla.
1 and 4.
Why?
Because they're
Nope, they're vertical. 1 and 4 are vertical angles. All right? So we've got angle 1 is congruent to angle 4 by VA, vertical angles. So now we've got 1 congruent to 4. Okay, what can I say next? Abby? Why did I make these congruent statements? Look at, what's common? Both statements have what? 4. Right, we can say 1 is equal to 5 by transitive, right? They both equal the same thing, so they're equal to each other. So we say angle 1 is congruent to angle 5 by transitive. Step 4, we can say if 1 and 5 are congruent, what is 1 and 5's relationship? What are they? Corresponding, and if by converse of corresponding angles, if the corresponding angles are congruent, then the lines are. So we can say G is parallel to H, and that's by converse of CA. Questions? Let's see if they did it the same way. Given vertical angles, transitive, corresponding angles, converse. All right. Theorem 3.7, the transitive property of parallel lines. The transitive property a parallel line says if two lines are parallel to the same line, they are parallel to each other. So again, it's like a chain. P is parallel to Q. Q is parallel to R. So then we can say P is parallel to R. P and R are parallel to the same line. They're both parallel to Q, so they're parallel to each other. Transitive property of parallel lines. Example, the flag of the United States has 13 alternating red and white stripes. Each stripe is parallel to the stripe immediately below it. Explain why the top stripe is parallel to the bottom stripe. What are we using here? It's just a big chain, right? S1 is parallel to S2, S2 is parallel to S3, S3 is parallel to S4, all the way down the line, right? So then you just continue to use transitive property over and over again, and you'd end up with 1 is congruent to 13. S1 congruent to 13. Explanation, all you need to say, transitive property of parallel lines. You don't need to write all that in the paragraph. If I were doing this if I assign this to you, just say transitive property of parallel lines. Three, 4. Find and use slopes of lines. Going back to some algebra in this section. Definition. The slope of a non-vertical line is a ratio of the vertical change rise to the horizontal change run between any 2 points on the line. It's rise over run. The The rise is the y values, the run is the x values. So it can also be written as y2 minus y1 over x2 minus x1. If a line in a coordinate plane passes through the points x1, y1 and x2, y2, then the slope m is going to be as shown. A negative slope falls from left to right. A positive slope rises from left to right. So if you start here and you're going to the right, you're going downhill. That's a negative slope. You start here, going left to right, uphill, positive slope. Zero slope. Zero slope would be horizontal, because your change in y's is the same number. Y, if I pick 2 points on this line, my y would be the same number. The y doesn't change, so you're subtracting the same number on top, and you get 0. Y is a vertical line undefined. Why do we say it's undefined? What would be your bottom number if you calculated the slope of a vertical line? Brandon? 0, and you can't divide by 0. Find the slopes of line A and line D. Okay, slope of line A. We've got, on line A, we've got 2 points. We've got 6,4 and 8,2. So our slope, we would do m equals y2. Or we'll call this 6,4 x1 y1. We'll call this x2 y2. So we have for our slope, we would have, if we do y2 first, we'd have 2 minus 4 over x2 would be first, 8 minus 6. So that equals to negative 2, 2, which is equal to negative 1. Our slope is negative 1. Now we're going to do the slope of line D. So line D, we've got these 2 points. So we'll call this x1, y1. We'll call this x2, y2. So if I plug into my formula, I would have m, and y2 would be 0 minus 4 and x2 would be 6 minus 6. So I end up with m equals negative 4 over 0. What is my slope? What would I say my slope is? Yep, it's undefined. Right. I would not even have to do the calculation. If I look on the graph and I see it as a vertical line, all you have to say is undefined. If they ask why, just say it's a vertical line. Everybody got it? Slopes of parallel lines. What do we know about the slopes of parallel lines? Kennedy? They're the same, right. Slopes of parallel lines are the same. Same slope. Slopes of perpendicular lines. You might remember what the slopes of perpendicular lines are. Slopes of perpendicular lines. Okay, they are inverse reciprocals or opposite reciprocals. Their product is -1. They go back. They said the two vertical lines are parallel because they're both undefined slope. But then going on to perpendicular lines, their slopes are opposite reciprocals. Horizontal lines and vertical lines are perpendicular as well. We can't say that their slopes are opposite reciprocals because the vertical lines is undefined. So you just have to know horizontal and vertical are opposite reciprocals. So opposite reciprocals would be if I had 3/4 as one slope, M1 equals 3/4. Then the opposite reciprocal M2 would be, opposite means the sign changes, negative, and reciprocal means you flip it. So it would be -4/3. Those two have opposite reciprocals. Those two lines would be perpendicular. Okay, which lines are parallel? Find the slope of each line. Go ahead and do that. Find the slopes of each of those lines. Do that on your own. And then you can check it with what I have. Remember, you're using for slope, you're using the formula m equals y2 minus y1 or x2 minus x1. That's the formula you're going to use. You're going to plug into that. Find the slope. Which lines were parallel? Eric. K1 and K2. Let's see. We do the slope of K1. We get 4. Slope of K2 was 4. The slope of K3 was 5. If you need help finding those slopes, raise your hand. I'll come around and I'll look at your work to show you how to do it. Does anybody want me to look at their work for finding slope? Everybody was able to do it. All right. Let's go on. Draw a perpendicular line. Line H passes through 3, 0 and 7, 6. The line perpendicular to H passes through the point 2, 5. Alright. And so let's see what they're asking us to do here. Okay, they're asking you to graph the line perpendicular to H that passes through 2, 5. They've already got the point on there, but the process, let's look at the process of doing that. I would find the slope of line H first. So first I would find the slope of line H. So we do M of line H is equal to 6 minus 0 over 7 minus 3. So that's going to be 6 over 4, which is equal to 2/3. Or 3, no, it's not 2/3, it equals 3/2. 3 over 2. Now, to find the slope of the red line, so we'll just call that M2, we're going to do the opposite reciprocal. What is the opposite reciprocal of 3 over 2? Yes, Brandon?
2 over 3.
Not just 2 over 3, but you forgot the opposite part. Evan? Negative 2 over 3. All right, and then how they did it to find another point, what they did is on the graph, they did that slope. They went down 2 and over 3. And that was the point on the line H of, they plotted the point and then they found its coordinates. Its coordinates were 5, 3. All right, next example. A skydiver made jumps with 3 parachutes. The graph shows the height of the skydiver from the time the parachute opened to the time of landing each jump. Which statement is true? The parachute opened at the same heights in jumps A and B. So when the time was 0, that would be their starting point. Is that true? At time 0, A and B are at different heights. This is your height. So that's not true. The parachute was open for the same amount of time in jumps B and C. Okay, B ends here. This is your time. B ends at around 4 seconds. C ends around 5 seconds. So that's not true. The skydiver descended at the same rate in jumps A and B. The slopes of the lines are different. So they're not the same rate. The skydiver descended at the same rate in jumps A and C. The slopes are the same. So their rise over run change is the same. Even though they're not the same line, they descended at the same rate because those lines are parallel. Okay.